Welcome to Simultaneous Equations Level 6. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving x squared minus y squared equals 8 and 3x equals y plus 8. Now, since we have a nonlinear and a linear equation here, we're going to solve these by substitution. But the first thing we need to do is change the linear equation so that either x or y is the subject. So looking at the linear equation, we have 3x is equal to y plus 8. And the easiest thing to do here is to make y the subject. And we can do this by subtracting this 8 from the right hand side. And we need to just make sure that we do the same on the left. So the left becomes 3x minus 8. And on the right, we just have y because the plus 8 and the minus 8 cancel out. Now that we have y as a subject, we know that 3x minus 8 is equal to y. So we can take 3x minus 8 and replace any y's in the nonlinear equation with this. So the first equation, x squared minus y squared is equal to 8, becomes x squared minus, and then in brackets we have 3x minus 8, because that's what we're substituting y for, squared is equal to 8. We now have an equation that's just in terms of x, so we can hopefully expand, simplify and solve to find the values of x. So firstly, we're going to deal with the bracket that's being squared. So we have x squared minus, and to square this bracket I'm going to write it out twice, so it's being multiplied by itself. So we have 3x minus 8 times 3x minus 8 is equal to 8. Now the minus in front of those two brackets is like a minus 1. So I'm going to write x squared minus 1 times, and now I'm going to expand the brackets. So we have 3x times 3x, which is 9x squared. 3x times minus 8 is minus 24x. Minus 8 times 3x is minus 24x again. And minus 8 times minus 8 is plus 64. We can close the bracket, and that's equal to 8. We could simplify the bracket, but I'm actually just going to expand again. So we have x squared, and now we're going to multiply everything in that bracket by minus 1. And all this does is just change the sign on each of those terms. So the 9x squared becomes a minus 9x squared. Both the minus 24x's become plus 24x's. So we have plus 24x, and 64 becomes minus 64. And that's equal to 8. I'm now going to simplify the left-hand side by collecting together the like terms. So we have x squared minus 9x squared. So that gives us minus 8x squared. We've got 24x plus 24x. So that's plus 48x. We have a minus 64, and that's equal to 8. To solve this quadratic, we now want to make one side equal to 0. And the easiest way to do this is to subtract 8 from the right-hand side. And we need to just make sure that we do the same on the left. So the equation becomes minus 8x squared plus 48x, minus 64 minus 8 is minus 72, and that's equal to 0. Now here we've got a minus 8 in front of the x squared, so we could go straight to the quadratic formula, substitute our values in and solve. Alternatively, we could divide everything in this equation by 8, or even divide everything by minus 8 to make the x squared term positive, and that tends to be something that we like to do. So I'm going to divide this whole equation by minus 8. So minus 8x squared divided by minus 8 is just x squared. 48x divided by 8 is minus 6x. And minus 72 divided by minus 8 gives us plus 9. And that's equal to 0. We can now try and factorize this. And we can do this by finding two numbers that multiply to make 9 and add to make minus 6. And those two numbers are minus 3 and minus 3. Because minus 3 added to minus 3 is minus 6, and minus 3 multiplied by minus 3 is positive 9. So we can factorize this by writing out two brackets. We need an x at the start of each one because x times x is what gives us x squared, and our two numbers minus 3 and minus 3 just go at the end of each bracket, and that's equal to 0. We now have two brackets that are being multiplied together to make 0, and for this to happen, one of those brackets has to be 0. So either x minus 3 is 0, or the second bracket x minus 3 is 0. But because they're the same, we just get one solution from this. So if x minus 3 is 0, we can add 3 to both sides to remove the minus 3 from the left, and this gives us x is equal to 3. So this is the first part of our solution. To find the corresponding value of y, we want to take our rearranged equation y is equal to 3x minus 8, because y is written as a subject here, and substitute in x is 3. So when x is equal to 3, this equation becomes y is equal to 3 times 3 minus 8. Well, 3 times 3 is 9, minus 8 gives us 1. So y is equal to 1. And this is a pair with x equals 3. So our final answer to problem 1 is x equals 3, y equals 1. In problem 2, we're solving x squared minus 9y minus x equals 2y squared minus 12, and x plus 2y minus 1 equals 0. Now, since the first equation is nonlinear and the second one is linear, we're going to solve these by substitution. And to do this, we want to write the linear equation so that either x or y is a subject. Now, looking at the second equation, x plus 2y minus 1 is equal to 0, it looks like it's going to be easiest to make x a subject. And I can do this by subtracting 2y from the left and doing the same on the right, and also adding 1 to the left and doing the same on the right. So on the left, the 2y and the minus 2y cancel out, and the minus 1 and the plus 1 cancel out, which just leave us with x, which is what we wanted. And on the right, we've got 0 minus 2y plus 1. So we can write this as minus 2y plus 1, or as 1 minus 2y. And now we have x as a subject. And if we know that x is equal to 1 minus 2y, we can take 1 minus 2y and substitute it into the first equation in place of x. So the first equation, x squared minus 9y minus x is equal to 2y squared minus 12, becomes 1 minus 2y squared, because we're substituting x for 1 minus 2y, minus 9y, minus, and then in brackets, 1 minus 2y, and these brackets are important because the minus in front of the bracket is showing it's being multiplied by minus 1. That's then equal to 2y squared minus 12. We now have an equation that only contains y, so we're going to expand, simplify, and hopefully solve. So looking at the first bracket, that's being squared, so this is the same as saying 1 minus 2y multiplied by itself. We have a minus 9y, and in the second bracket we can actually expand straight away. So minus 1 times 1 gives us minus 1, and minus 1 multiplied by minus 2y gives us plus 2y. And that's equal to 2y squared minus 12. Going back to the left, we can now expand those two brackets. So we can start by multiplying together 1 and 1, which gives us 1. Then 1 times minus 2y is minus 2y. Then minus 2y times 1 is minus 2y. And finally, minus 2y times minus 2y is plus 4y squared. And we still have our minus 9y minus 1 plus 2y is equal to 2y squared minus 12. Going back over to the left, we can now simplify this by collecting together the like terms. So starting with the y squared, we just have a 4y squared. Moving on to our y's, we have a minus 2y, a minus 2y, which is minus 4y, minus another 9y is minus 13y, and then plus 2y gives us minus 11y. We also have a 1 and a minus 1, which has become 0. So we have 4y squared minus 11y is equal to 2y squared minus 12. Now this is a quadratic equation, and so to solve it we want it to be equal to 0. And so we're going to make the right hand side 0 by subtracting 2y squared from the right and making sure we do the same on the left. So this gives us 4y squared minus 2y squared, which is 2y squared, minus 11y, and on the right we just left with minus 12. We now need to remove the minus 12 from the right, and we can do this by adding 12 to the right and doing the same to the left. And so the left becomes 2y squared minus 11y plus 12, and that's equal to 0. There are different ways to solve this quadratic. Since there's a number in front of the y squared that's not 1, I'm going to solve this by using the quadratic formula, but you could also try and factorise. Now before we can use this formula, we need to establish the values of a, b and c. Now a is always a number in front of the y squared, so that's 2. B is the number in front of the y, so that's minus 11, and C is the number that's on its own, or the constant, which is 12. Substituting these into the quadratic formula gives y, because our equation is written in terms of y, is equal to minus b, or b is minus 11, so minus 11 gives us positive 11, plus or minus the square root of b squared. Now, because b is minus 11, it's important that when we square it, we put it in brackets. So minus 11 squared minus 4 times a, which is 2, times c, which is 12, all divided by 2a, which is 2 times 2. And if we calculate this using a plus on the numerator, we have y is equal to 4. And if we calculate this with a minus on the numerator, we get y is equal to 3 over 2, or 1.5. So these form the first part of our solution. To find the corresponding values of x, we're going to take our rearranged equation, x equals 1 minus 2y, because x is the subject already, and substitute in our two values of y. So when y is 4, this becomes x is equal to 1 minus 2 times 4. 2 times 4 is 8, and 1 minus 8 is minus 7. So x equals minus 7, and these form our first pair. If we now look at when y is equal to 3 over 2 and substitute this in, we get x is equal to 1 minus 2 times 3 over 2. Well, 2 times 3 over 2 is 3, and 1 minus 3 gives us minus 2. So this is our second pair. And so our final solution to problem 2 is x is equal to minus 7, y is equal to 4, and x is equal to minus 2, y is equal to 3 over 2. In problem 3, we're asked to find the coordinates of the points where the lines with equations x squared minus 3y squared equals 13 and 2x plus 3y equals 4 meet. Now, when we're asked to find the coordinates of where two lines meet, what we always need to do is solve their equations simultaneously and write our solutions as coordinates. Now, looking at these two equations, one is nonlinear and one is linear, so we need to solve these by substitution. And what we want to do is rearrange the linear equation, so the second one, so that either x or y is the subject. So starting with 2x plus 3y is equal to 4, I'm going to make x the subject. So I'm going to first subtract 3y from both sides. And this gives 2x is equal to 4 minus 3y. To now make x a subject, I need to divide everything by 2. So I'm going to divide the left side by 2 and also the right side by 2. So this gives us x is equal to 4 minus 3y all over 2. Now that we know that x is equal to 4 minus 3y over 2, we can take this fraction, and in the first equation, wherever we're seeing x, we can substitute it for this fraction. So our first equation, x squared minus 3y squared is equal to 13, becomes, in brackets, 4 minus 3y all over 2 squared minus 3y squared is equal to 13. And we now have an equation that's just in terms of y. So we need to expand, simplify, rearrange, and solve. Starting with 4 minus 3y over 2 all squared, when you square a fraction, it's equivalent to squaring the numerator and squaring the denominator separately. So I'm going to rewrite this as 4 minus 3y in brackets all squared, divided by 2 squared, which is just 4 minus 3y squared is equal to 13. Now on the numerator, we're squaring a bracket. So we can rewrite this as 4 minus 3y multiplied by 4 minus 3y all divided by 4. And in our next step, we're going to expand that numerator. So to expand the numerator, we can first multiply together 4 and 4, which gives us 16. And then 4 and minus 3y is minus 12y. Minus 3y multiplied by 4 is again minus 12y. And minus 3y times minus 3y is plus 9y squared. Need to remember that this is all being divided by 4. We have a minus 3y squared, and it's equal 13. We can simplify the numerator of the fraction by collecting together the minus 12y and the minus 12y, so this becomes 16 minus 24y plus 9y squared, all divided by 4, minus 3y squared is equal 13. We can now look at getting rid of that fraction. And because the numerator is being divided by 4, we can multiply everything in the equation by 4. So if we multiply the fraction by 4, this eliminates the denominator and just leaves us with 16 minus 24y plus 9y squared. We also need to multiply the minus 3y squared by 4. So this is minus 12y squared. And we also need to multiply the 13 by 4, which gives us 52. We can now simplify the left side of this equation by collecting together the like terms. So we have 9y squared minus 12y squared, which gives us minus 3y squared. And we still have a minus 24y, a plus 16, and that's equal to 52. Now we're solving a quadratic here, so we want one side to be equal to 0. So to achieve this, we can subtract 52 from the right and make sure that we do the same on the left. So the equation becomes minus 3y squared minus 24y, and then 16 minus 52 gives us minus 36 is equal to, and 52 minus 52 is 0. Now we could try and solve this quadratic by going straight to the quadratic formula because the number in front of the y squared is not 1. But here we can actually divide every term by minus 3 to give us a y squared at the beginning. So if we divide every term by minus 3, this gives us y squared. Minus 24 divided by minus 3 gives us plus 8y. And minus 36 divided by minus 3 is plus 12. And 0 divided by minus 3 is just 0. So now that we just have a single y squared at the start of this equation, we can try and solve this by factorising. So we're looking for two numbers that multiply to make 12 and add to make 8. And those numbers are 6 and 2, because 6 plus 2 is 8 and 6 times 2 is 12. So to factorise this, we're going to have two brackets, each of them with a y at the start, because we need y times y to make y squared. At the end of each bracket, we're going to have our two numbers, plus 6, plus 2, and that's equal to 0. Now here, our first bracket multiplied by a second bracket is equal to 0. So this means either the first bracket has to be 0 or the second bracket has to be 0. And solving each of these independently, we have y is equal to minus 6 and y is equal to minus 2. And these form the first part of our solution. To find the value of x, we now want to take our rearranged equation, x is equal to 4 minus 3y over 2, and substitute our y values into this. So starting with y equals minus 6, this becomes x is equal to 4 minus 3 times minus 6 all over 2. And this gives us x is equal to 11. So these form our first pair. If we also look at when y is equal to minus 2 and substitute this in, we have x is equal to 4 minus 3 times minus 2 all divided by 2. And this gives us x is equal to 5. And this forms our second pair. So these two lines are going to meet at the points with coordinates. Well, from our first pair, we have an x coordinate of 11 and a y coordinate of minus 6. So they're going to meet at the point 11 minus 6. And from our second pair, we have an x coordinate of 5 and a y coordinate of minus 2. So they're going to meet also at the point 5 minus 2.